Good morning. It's my pleasure to be the chairman of the opening talk of this meeting that will be given by Professor Henrique Leitão. Henrique Leitão is a historian of science and is the chair of the Department of History and Philosophy of Science at the University of Lisbon. He has several awards and recognitions that go well behind the Academy, in particular the Prêmio Pessoa awarded to distinguished personalities in art, science, and literature. Today he's talking about Magellan expedition in the 16th century and the cartography of that time. Please feel free to use the chat to leave your questions throughout the talk. In the end, there will be some time to address these questions. Please welcome Professor Henrique Leitão. The floor is yours.
Thank you very much. I don't know if I'm online already. Thank you very much, Rogério. It is obviously a great honor and a great privilege to be here, and I'm absolutely delighted, but also humbled to be in the company of a truly superb line of extraordinary mathematicians. And I congratulate the organizers for this, and also, for this immense recognition that they gave me in inviting me to be here. But not only that. Being invited by SPM, it's also in itself a great recognition. SPM has become along the years a major player in the cultural landscape of Portugal, and it would be very hard to understand the history of academia and of cultural life in our country in the past decades without bringing to mind the role played by SPM. So also because of that, I am truly honored to be here. Let me try to share my screen. I do not have the share screen facility available. I am disabled. If someone can take care of this so that I can share my screen. Well, in the meantime, oh yes, now it's okay. Thank you very much. Oops, there you go. Yeah, I think now you have the image. I think everything is correct now. So, having said these very initial words, I feel like I am in a rock concert where we have, a modest band that opens and warms up the event so that the main gig follows afterwards. And I'm very conscious of my role. So I hope that. Having said these very initial words, I feel like I am in a rock concert where we have, a modest band that opens and warms up the event so that the main gig follows afterwards. And I'm very conscious of my role. So I hope that. Okay, I was getting a feedback sign. I know. So, I want to talk about, the Moluccas question. What is the motive for bringing this topic here? Well, what is my objective? Well, I will be talking about what is a major scientific problem in the 16th century, which is nowadays almost completely forgotten, but for about 1 century, concentrated the attention of many scholars and scientists and many mathematicians. Now, the problem that I will be talking about emerged due to the fact that by late 15th century, long distance oceanic voyages became regular. And as we will see, this fact had immense implications and many consequences. Finally, and this is one of the other reasons why I mentioned this problem, is that because it was a problem of enormous political and at the time imperial consequences, although at its core it was a very mathematical and geometrical issue. So this is a very not so common situation when a mathematical or at least a geometrical problem has consequences that go all over, much beyond the strictly intellectual realm. This is work that I've been doing together with a colleague, Joaquim Alves Gaspar. We've been doing this for some years. So part of it is already published, and we will continue working. So some of it is new, and we will be publishing it in the near future. Okay, so let us start. By the 1st century after Christ, a man called Claudius Ptolemy, everybody has heard about Ptolemy, published a book called the Geography or the Cosmography. Ptolemy's Geography is a book on how to make maps, essentially. So it is divided in 8 chapters that were called books, but only the first one has truly text with explanations and some theoretical part. All the others are lists of longitudes and latitudes of locations. And this is an example. This page here is an example of a later manuscript with lists of longitudes and latitudes of places. And this was the idea that Ptolemy bring about. With these lists of latitudes and longitudes, Ptolemy gave rules on how to make maps, which are essentially, and I will not be going into the details, are essentially maps that are coordinated by longitudes and latitude scales here. This is one of those maps. Another one you will see here, latitude scale and a longitude scale. Okay. So then Ptolemy also explains, and this is, 1st century, how to determine the latitude and the longitude of each place. Well, the latitude is a simple problem. It's not very difficult. There are several astronomical means that give the latitude with considerable precision. So this is not a problem. In particular, there is a very simple result that states, and this is a good exercise for young students, that states that the height or the altitude of the celestial North Pole is equal to the local latitude. So this is the way to do it. So let's leave aside. Latitude is an easy problem. The longitude is harder to find, but Ptolemy gives 2 suggestions. He says, well, we can measure longitude, just by, counting the distance that we travel on the surface of the Earth. It's an approximate method, but it will work for short distances. And this is how he finds, the longitude of many places, by estimating the distance traveled. Or he says, we can use eclipses. So there is an astronomical procedure to determine longitude. How does it work? Well, it works more or less in this manner. This is a drawing that everybody gets in the internet. So let me explain. Suppose that we are at a certain place, let us say Seville, and that we have an unique astronomical event, for example, an eclipse, and that we have tables that tell us at what time in this meridian the astronomical event will take place. So we have tables that tell us that the eclipse will take place at this meridian at a certain moment. Now, suppose that you measure, that you are in a faraway place now, and you measure the moment when the same event, astronomical event, took place. Then it is an easy matter to see that the difference in time of these 2 events will give us the longitude, the difference in longitude. And this is what Ptolemy suggests. Now, in order to do this, we need a number of things. First, you need to make the observation of the eclipse. So you need to have, be a reasonable observer. And then you need to have tables of eclipses at specific meridians. But these were very common. And I'm showing here what table that, this is, late 15th century, but there are many earlier examples of tables that give us conjunctions and oppositions of sun and moon. And as you know, eclipses take place in some of those conjunctions or oppositions. So these tables were not rare. They were easy to get by. Still, they were not, super accurate, but it was enough. The problem is that in order to apply this technique, you need to know the time, the local time at your place, so that you then compare with the tables. And this was, as you know, a problem. But anyway, so Ptolemy gave a procedure, and actually he seems to have used this procedure to establish some of the longitudes. So Ptolemy's contribution was of enormous importance, and we will call it the Ptolemaic prescription to make maps. So what is the Ptolemaic prescription to make maps? It is very simple. We determine the positions of places at the surface of the Earth with, longitude and latitude, and then we devise a mathematical procedure, a projection, and Ptolemy suggests 3 projections. We devise a procedure to transport those places, those coordinates in the surface of the Earth into coordinates in the plane, XY plane. This, we will call this the Ptolemaic prescription. This is, as everybody can see, this is very modern. This is very modern, and it's a major breakthrough that Ptolemy made. Now the question is, were nautical charts being made according to this prescription? And the answer is no. So nautical charts in the Middle Ages and the early modern period, and this is an example of such a nautical chart. I think you can see this is the Mediterranean, this is the north coast of Africa, and this is the Greek area, and you have here Italy, etc. Everybody has seen this type of charts. It's the Portland chart. These are called Portland charts. These charts are not made following a Ptolemaic prescription. Now, another example, this is a later chart, but the technique is precisely the same. And here you see not only the Mediterranean, which is very neatly, nicely drawn, but also, an important part of the coast of Africa. But this is a Portuguese chart of the end of the 15th century. But these charts are not made with latitudes and longitudes. So how are these charts constructed? Well, nautical charts are constructed using the procedures of nautical navigation, of displacement at sea. So you go on a ship, and the way you use to move on a ship, you also use to establish places, to locate places. And the traditional manner was the following. If you have, a point of departure, a sailor would, sail at a certain course, and the course was established by a magnetic compass, and at a certain distance, and this would give the point of arrival. And on this technique, this final point was called the point of fantasy. And the name fantasy has to do with the fact that it was recognized that estimating a distance at sea is always a tricky affair. It was very much affected by error. So this is essentially, polar coordinates, let us say. But the important point to note is that this was the way to make those beautiful Portland charts. You use directions and courses and distances. No latitude or longitude are used, and this is usually some miscomprehension of many people who look at nautical cartography and assume that nautical cartography was made using the same type of approach that you have in modern maps or in Ptolemaic geographical maps. No, they were made in a completely different manner. Now, how were these charts made? Well, they were constructed in a very rough manner, because at each point, the sailor would, determine with course and distance a new location, and then the course and the distance were transferred to a plain sheet as if the Earth was flat. Well, not because they did not know that the Earth was spherical. Everybody knew that the Earth was spherical, but just as a very rough approximation, okay? And the chart was constructed iteratively. So you would, set one point, and from that point, you would then, move to another point and determine the next point, and then the next point. And from this, the landscape was designed, okay? Now, this worked very well during the Middle Ages, but there are many examples of superb charts for the Mediterranean, especially in some northern parts of Europe, for the Mediterranean during the Middle Ages. But what happens is that by mid 15th century, you have this new phenomenon, and the new phenomenon is enormous long distance oceanic voyages. So there is an enormous change in scale. Okay. And this change in scale in the navigation will translate, and also in the need to have maps with a much larger scale, and new problems will emerge from this, problems that were not felt when one worked with the small scale of Mediterranean cartography, but now they will become apparent if you want to make these enormous voyages. Now, one of the things that needed to be corrected was the technique to make charts. So the technique was immediately, this is, late 15th century, and, maps started to change. We have the first examples of maps that use this new technique at the very beginning of the 16th century. And the technique now became, a sailor would start from a point of departure. He would follow a certain course determined by a compass, but then he would not estimate the distance traveled, the tricky part of the business. He would make a measurement of latitude. And with course and latitude, you can know where now you are. So now the two variables of interest in nautical cartography, and let us say, in a broad manner, after the 16th century, are the direction, the course, and the latitude. And as you can see, longitude is not used. And this is important. I would like to emphasize yet one more time, longitude is not a parameter used in nautical cartography in the 16th century. Not because it was difficult, not only because it was difficult to measure, we know that it was difficult to measure, but because all nautical cartography developed using this different procedure, which was pretty efficacious. You could do everything. And then course and latitudes were transferred to the plane, to a plane sheet, as if the Earth was flat, not taking into account the sphericity problems. So, okay. Now, all of this were the techniques, and as I said, they function very well until the scale of the problems started to show their inherent problems and difficulties. And the first instance of this was during the Treaty of Tordesillas. So everybody knows this. In 1494, after a series of preparatory diplomatic agreements, Portugal and Castille established an agreement. It was, from an imperial point of view, slightly demented, but I'm not commenting on that now. I'm only interested on the technical part. They established an agreement according to which a line should divide two areas of influence between Portugal and Castile, and this line should be established at 370 leagues east of Cape Verde, so in that direction. And this was the treaty. Let us see what was the actual phrasing of the treaty. The treaty said that a boundary or straight line be determined and drawn north and south from pole to pole on the said ocean sea, that is the Atlantic, from the Arctic to the Antarctic pole. This boundary or line shall be drawn straight, as aforesaid, at a distance of 370 leagues west of the Cape Verde Islands, being calculated by degrees or by any other manner, etc., etc. Now, let me make a number of comments on the Treaty of Tordesillas. Well, first, it is clearly about a line that needs to come from pole to pole in the Atlantic. So it's a meridian, but it's only in a part of the sphere. So it's a semi-meridian, okay, in the Atlantic. There's no doubt about this. Astronomical means are never mentioned in the treaty. This is only part of it. Longitude, for example, is never mentioned. So it is more or less implicit that these 370 leagues west of Cape Verde should be determined by, a direct measurement of distance, which was not difficult to make. Okay. There is some ambiguity with these 370 leagues because they only said eastward of Cape Verde, but which island of Cape Verde? There are a number of islands, to the westernmost. There's some point of discussion. And then to another topic, technical commissions were established to draw the line. And now, what happened was that when people started looking carefully at the problem, they started realizing that it was much harder than previously considered. Not because it was difficult to determine where was the point 370 leagues west of Cape Verde Islands, that is the easy part, but because it was not clear how to draw a meridian from passing from that point. Here we have an attempt in the Cantino planisphere, 1502, immediately afterwards, where the meridian, Tordesillas meridian, is drawn as a straight line that goes like this. But is this correct? Now, Ferrer, the experts of the Castilian crown that looked into the problem, just in 1495, 1 year afterward, when they had to decide where that line would go through, he immediately realized that the problem was much harder than previously thought. Ferrer compared nautical charts with Ptolemaic maps and concluded that this was much more difficult. Actually, he did not make a final solution to the problem, but he made a very interesting remark. He said, in order to be able to draw this line, one needs to be, at the same time, a cosmographer, a mathematician, and a sailor. So what is the problem? Why is it so difficult to draw that line? Isn't it correct to do it like in the Cantino planisphere, just drawing a meridian, vertical line? Well, today we can understand what the problem is. This is, a study of the Cantino map by a colleague of mine, by Joaquim Gaspar, in which, some points are georeferenced. So you take notable points, and then these lines are the implicit, not explicit, but the implicit meridians and parallels of that map. This is tools that have been developed recently, and they are extremely helpful to understand what is going on in the geometry of these lines. I don't have the time to comment everything. We could stay here many hours commenting because all of these deformations are of enormous importance. But let me just make two brief observations. If you look at the coast of Africa, you will notice that parallels are horizontal, roughly horizontal, and this is a direct confirmation that latitude measurements were made in this area, and we know by other sources that these points here were determined by latitude measurements, and so latitudes are okay. Then you see that there is some deformation in this area because the Mediterranean comes from older maps, it's drawn from older maps. But the point, and then there are other deformations, but the point that we need to look into is here. Now, here we see the problem that Ferrer hinted, but could not solve. And the problem is that in this map, a vertical line is not a meridian. Meridians are like this, are curved, they converge. The intrinsic meridians are like this. So in the way of producing this chart, it was inherently, the geometry of it contains inherently as an inner property the fact that its meridians are like this. when the meridian of Tordesillas is an exterior line that is put in top of this, and it does not correspond to the meridian of Tordesillas as the treaty conceived. And this is the problem that this technician Ferrer became aware of, although he was impossible. He was not able to solve. Now, Joaquim and I, we have discussed this in careful detail in some publications, and in order to understand this, we always talk about, the inner geometry. The inner geometry is the geometry that you see in these lines that is made evident with these mathematical tools that we have nowadays. This is the inner geometry of the map, and the external geometry. The external geometry is the lines that they draw on the map. In this case, for example, an example of external geometry is this Tordesillas line that they thought it was a meridian, but it was not. And this clearly makes it apparent, the problem of nautical charts. Nautical charts, not only they are not constructed with a Ptolemaic prescription, they are constructed in a completely different manner. They have no projection, they contain no longitudes, they are, another matter, but they also, due to the manner in which they are constructed, they have a very complex and somewhat uncontrolled inner geometry. And the consequences of this were immense. But there is still more to comment. As everybody knows, there is this phenomenon of magnetic variation. That means, compass line needles do not point to geographical north, they point to magnetic north. And this was being, discovered along the 16th century, mostly by Portuguese pilots. Magnetic variation was known for, some centuries before in Europe, but it was believed to be a faulty or erroneous, problem with the needles. It was only when sailors started, moving around in long distances at sea with magnetic needles that they realized that magnetic variation or magnetic declination was not an error of the compass, but it was a pattern. It was a true phenomenon of nature. And also that it was a smooth variation and etc. And it was a property that varied, with place from point to point, okay? And as you perhaps heard, some pilots suggested that one could perhaps, measure longitude by magnetic variation. This was an idea that was very popular, but it was also rapidly, shown to be wrong. But the problem is that you have magnetic variation. Now, sailors rapidly realized that since when you sail, you use the direction of your magnetic compass, then you could have, big changes on account of the fact of magnetic variation. That is, magnetic variation could influence cartography. And this is very obvious to see in a broad manner. And one of the first statements of a person fully aware of the problem is by this man, this João de Lisboa, Portuguese, a very famous Portuguese pilot, in 1514, when he wrote a treatise on the compass. And he very clearly says, and I will read it and then we'll interpret it, and so that this could be corrected, it would be necessary to navigate by the truth, despite the fact that near the coast, while it is not corrected, you should only navigate by what it is usual, because the false must be navigated falsely and the true truthfully. Now, this is a little bit cryptic, but from other parts we understand what he's saying is the following. There is something called to navigate by the truth. That is, navigation correcting the directions, and so correcting for magnetic declination. You compensate and you correct. This is navigate by the truth. But this is not what pilots usually did. What pilots usually did, and he says navigating by what it is usual, was navigating using the magnetic declination, the values given by the compass. So when in a map, a pilot says, I'm heading north, he means he's heading magnetic north, not necessarily magnetic geographical north. Now, the problem with this is that, as we saw, charts were made with the navigational procedures. So charts were deeply affected by the fact that they had been drawn using magnetic courses and not geographical true courses. So there are variations in the charts due to this fact. So, but what happens when you do not compensate and when you use magnetic courses and not the geographical ones? Well, if you use the first procedure that I mentioned before, where you measure the distance that you run and then you measure your course, if you do this, the fact that you follow magnetic courses and not the real courses will, the effect of this will be a small tilt in your coastlines. So here we'll see, coastlines will be slightly tilted, rotated, okay? If you use the second procedure that I've mentioned, where you navigate by following a certain course and then determining latitude, since you have like a fixed point in the latitude that you determine, the effect of following a magnetic course and not following the real course, the effect is not a rotation, but it's a lateral displacement. So in order to summarize, and this would take a little bit longer to explain in detail, but I'm pretty sure everybody understood, to summarize, the consequence of pilots making charts following geographical course directions and not the true geographical ones in the 16th century is that you will have lateral displacements in the position. By lateral displacements, I mean longitudinal displacements. And this is why nautical charts will show displacements in longitude, not because they are, in a sense, wrong. They are not wrong because, as I said, longitude is not a parameter of nautical charts. So they are in terms, it's like a degree of freedom in a nautical chart, the longitude, but also because since you have this phenomenon of using magnetic courses, you will have this lateral displacements. And this is what we can see nowadays. Here you can see analysis that show the tilt. So this is, the old technique of course and distance, and you have this tilt. It is nowadays, it is well known that these Portland charts, they all have this tilt, and this tilt is directly connected with the average value of magnetic declination in the Mediterranean in this period. So there is a rotation there. But also, more interestingly, it can be easily shown that with the values of the magnetic field in the Atlantic and of the values of the magnetic field in the Indian Ocean, you will have, as an effect, a displacement of Africa to the east side. So if we put, this is what you get. 16th century maps show Africa displaced to the east, and this is this is superimposed with a correct real Google Earth and a line outline, and you can see the displacement, and there are other errors, but the main trend, the main explanation for this is the fact that these coasts were charted using magnetic lines, magnetic rumps, and those magnetic rumps will lead to these displacements. Okay. So this is very important to understand this geometry that we understand nowadays, because everything will unfold from here. And this is the background to understand what is the Moluccas question, because if we don't understand this technical background, we will not understand the discussion. And this is a problem of many historians who do not understand that at the core of this enormous debate about the Moluccas question was a very subtle and difficult to understand technical problem that only very few people in the 16th century understood, and that we nowadays can understand in great detail because we have these computer techniques and etc. Now, what is the Moluccas question? Well, first, just to remind the geography, there are some lines here, the Moluccas or Spice Islands in this area here. And there is also another place, which is Malacca. Malacca is a town there between Kuala Lumpur and Singapore. It's a place there, a very important place. But so this is geography, okay? So what happened was the following. In 1509, the Portuguese secured control of the Indian Ocean. And in 1511, they captured Malacca, okay? Now, immediately after capturing Malacca, an expedition was sent to the Moluccas. The Moluccas were, in 1512, a Portuguese expedition reached the Moluccas. The Moluccas were well known for the spices that they produce. And spices, there are many, huge profits that could be made with the commerce of spices. So this is, the background, the commercial and imperial background. So, but because of this, what happened was that immediately starting in around 1511, some Spanish people, but also some Portuguese, which is interesting, started writing that the Moluccas and even Malacca were on the Castilian side of the demarcation line. What are they talking about? So this starts immediately in 1512. What are they talking about? Well, as you saw, the Tordesillas treaties established a line of demarcation here, but this was only half of the story. The Tordesillas treaties did not refer it, but later, Portugal and Castille were aware that the full meridian should pass on the other side of the earth. And now, one of those coincidences of history, it passed very near the Moluccas archipelago, but the discussion was how near, that is, where are actually the Moluccas? On the Portuguese side, that would mean to the west, or on the Spanish side, that would mean to that part over there. So this was a question which immediately started in 1511. And now this is very interesting because longitude determination had been a completely dormant question during the Middle Ages. So, Ptolemy mentioned longitudes and eclipses to measure longitudes, but all throughout the Middle Ages, almost no one ever mentioned longitudes again until 1511, when the Moluccas problem appeared. Where are the Moluccas? And where are the Moluccas is a question about the longitude of the Moluccas. So it is an imperial question of imperial and political and economic value at the time, but it is also a very technical question. Where are these islands? And the solution was to determine the longitude. So suddenly, the dormant problem of longitude became an enormous problem of enormous relevance. And I just put some of the events, because after 1510, 1511, you see activity all around, first Iberia, but then in Europe, about the measurement of longitude. I'm going very fastly, classes on how to make longitude appear. There are people who start making instruments to determine longitude. In Germany, a very famous astronomer, Johann Werner, presents a method, by a lunar distance method to determine. Johann Schöner also writes a book explaining this method. João de Lisboa, this pilot, suggests magnetic variation. And Rui Faleiro will mention in the Magellan's Voyage will provide methods to determine longitude, and André San Martin in the 20s during Voyage will make measurements of longitude. What I mean is, it is no coincidence at all that research on the measurement of longitude starts at this moment. It starts on this moment because now it was a critical issue. Okay. This is one of the techniques that was invented at the period, by lunar distances, not by eclipses, as Ptolemy has said, but with tables of the motion of the moon. I'm skipping the details. And all of this story is the background for Ferdinand Magellan's voyage. What happened was that Ferdinand Magellan approached the king of Spain at the period, this young man, Charles I, and he approached him with this map. This is a very famous, Kunstmann 4 map. This is Portuguese, it's a Portuguese map. And in this map, and this is a very, very uncommon map because it's one of the very few where there is a longitude line here, and longitude is marked. In this map, the Moluccas are marked there, and they are clearly, I have not put the numbers, but they are clearly on the Spanish side. So Magellan brings to the Spanish king a Portuguese map that shows that the Moluccas are on the Spanish side. And this is what convinces the king to start the voyage. So the spice expedition, Magellan's voyage, is to reach the Moluccas by the Spanish side, discovering a passage, and then to confirm that the Moluccas are on the so-called Spanish side, and then to return, sailing from the Spanish side. And it's because the position of the Moluccas, that is the longitude of the Moluccas, are so critical that when the expedition starts, it starts with a double leadership. The leadership was divided between Magellan, which was a sea captain, and Faleiro, who was a mathematician. And I think the audience would like to know that the most famous sea voyage started with a mathematician, at an equivalent position as Magellan. Now, this is the voyage, as you know, I'm not going to comment, but the important thing is that the mathematician, which ended up not going in the voyage because then he could not go, but he left a report, and the report is here on how to measure longitude of the Moluccas. But now you see the problem. Maps, charts were showing that the Moluccas are on the Spanish side, but they needed to make a precise measurement there of longitude. And this is what Faleiro argues here. The voyage, very important. The Strait of Magellan was crossed, and then the crossing of the Pacific, an absolutely stunning nautical feat with unparalleled nautical feat. The largest ocean on the earth crossed from one side to the other side at first attempt. So this is remarkable. But the problem was the following: where are the Moluccas? So this is the anti-meridian. This is where the Kunstmann map showed the position of the Moluccas. This is what Magellan believes. But in truth, it happens that the Moluccas are on the Portuguese side. And apparently, during this voyage, a man called Andrés de San Martin, upon reaching that location, made a measurement of longitude and concluded that the Moluccas are on the Portuguese side. Now, the consequences of this voyage were enormous. Very rapidly, the Portuguese king was, furious, of course, and said, well, the Moluccas are not from Spain, so they complained, and the Spanish king saying, no, the Moluccas on our side. So a juntas, so that means a diplomatic meetings were set to solve the problem. Where are the Moluccas? It's very interesting that from the very beginning, the technical part was very heavy. If you can see, it was decided in those meetings that not only diplomats and a legal team should be there, but also a very technical team. For example, the Portuguese team during those discussions were 3 diplomats, law people, but then 3 mathematicians and 3 pilots. So 2/3 of the personnel in those discussions were technical personnel. And the same thing with the Spanish team. But now a very interesting thing occurred. Now, they had to decide the property and the possession. Let's skip the legal talk. The property is the location of the Moluccas. So let's stick only to the property, the location. And the Portuguese king said, the location will be decided by our scientists, the scientists and the mathematicians and the astronomers, okay? But then he said, the astrologers, that means it's a broad term meaning astronomers, mathematicians, that we send to tackle the issue of property are instructed that in no way it is to be accepted that the demarcation is made, if not by eclipses of the moon, if not by astronomical determination of longitude. And although nautical charts and globes can be used during the conversations, this is the Portuguese king ordering, this manner, the observation of eclipse, will be the true and final one. This is an extremely important point. So when the sessions, the diplomatic sessions start, the Portuguese party demands that the position of the Moluccas should be determined astronomically. And there is an enormous discussion on how this could be made. And during this discussion, for example, one of the Spanish people, Ferdinand Columbus, the son of the Christopher Columbus, is the first person to suggest the use of watches, of timekeeping devices to measure longitude. As we know, this will be the final solution in the 18th century. But it was for the first time proposed here. Now, the interesting thing is that the Castilian side refuses longitude measurements and says we should use charts. Why? Because as I shown before, charts placed the Moluccas on the Spanish side. But the Portuguese at this moment were already convinced that those charts were not correct, because they knew that due to a number of effects, you had, this longitudinal displacements. So an enormous debate. I have, 5 minutes more, I think. I will go fastly to finish. An enormous debate on the geometry of nautical charts ensued. And this is a debate that started in the 20s and lasted until the end of the 16th century. And now the problems, the terms of this debate, because this inner geometry of nautical charts is very complex, and it gives effects that are not easy to grasp. For example, other people intervened. This is, Duke of Bragança, who sent a memorandum saying that in no way should the Portuguese accept nautical charts to determine the position of the Moluccas. And why? And explain, because the nautical charts have many problems. They have, there is this difference between the sphere and the plane. There are problems. There are exaggerations in the distance. There are errors in longitude, etc. But then he made a truly prescient remark when he said that trying to correct longitudes in nautical charts could lead to even greater errors. So there was not, this is the opinion of this man, and he's absolutely correct, there is no possibility to make a simple correction in a nautical chart by adjusting the longitudes. And, I can comment, if you just simply adjust the longitudes, you will affect the courses of the coastlines, and the courses are what pilots use. So in 1537, the leading Portuguese of the period entered into the fray, and he wrote a treatise explaining the geometry of the nautical chart. I will not comment on his ideas, but it is the first text ever to address the geometrical problem of what is going on in a nautical chart. Nunes goes far in his analysis, but he does not provide a complete and total solution. But in any case, it is the first attempt at understanding what is going on with the geometry of a nautical chart. The debate continues, and in 1938, this very famous Portuguese pilot, João de Castro, comments that the distance, and he notes that the distance, as we saw before, between the coast of Brazil and the coast of Africa is very exaggerated. That is, in contemporary charts, that is, Africa is much displaced to the east. And he correctly explains that this is a consequence of magnetic variation. And then he also warns the king that it is because of this displacement of Africa that the Moluccas Islands are then displaced even further to the east, and they fall on the Spanish side. So it is truly surprising that the enormous discussion about the position of the Moluccas has at its core the effect of magnetic declination in the way to make charts. And so it was clear, and just one or two examples, I'm reaching the end. just one or two examples more of attempts to tackle this problem. It was clear by mid-16th century that charts needed to be corrected. Like Martin Cortés says in this text, it's necessary to correct these charts, but nobody was very aware on how to do it. And for example, Nunes himself tried just to take a nautical chart and correct it using good longitude measurements, but this completely ruined the chart to a point that pilots refused to use those charts. By the end of the 16th century, Edward Wright, the major theoretician, English theoretician of nautical methods, wrote, and it's a long excerpt, I'm not going to read it all, but just saying, well, the charts, they have this problem because, rums were not correctly taken into account, magnetic rums, and they have this problem. And I mean, we need to solve this, basically. This was by the end of the 16th century. So I drastically summarize what was an enormous discussion motivated by the Moluccas question. To conclude, now the Moluccas question, which is basically, where are the Moluccas, and should we decide this based on our charts, or should we decide this based on longitude measurements, and the consequences of this? This was an open issue and a major scientific debate during the 16th century. It gave rise to enormous diplomatic debates, never-ending, bickering, political discussions, and extraordinary sea voyages. It was the question that launched the longitude problem as a serious scientific challenge. But it was not merely a consequence of the difficulties in measuring longitude. Contrary to a popular perception, longitude did not become a crucial issue because of wreckages. There are very, very few wreckages that happened because of wrong longitude measurements. Right? Very few. There are some, but very few. What really stirred the problem was this, very imperial discussion, of course, but very, very important. Now, but it was not only the difficulty in measuring longitude, it was harder than that. It was the progressive awareness that nautical charts and Ptolemaic maps, Ptolemaic prescription, latitude, longitude, were two cartographic paradigms that were incompatible. And to finalize, my final reflection, that at the core of this big discussion and big question were geometrical and mathematical arguments, is something that I believe this audience will appreciate. Thank you very much.
Thank you so much for this wonderful and interesting talk. There is not so that much room for questions, but anyway, I think you can address Professor Henrique directly during the event and ask your questions. Right now, we must be strict with our times because we have right now the sessions that are almost starting. And so maybe you can give a round of applause to our Professor Henrique Leitão. You have some emojis where you can use to applaud. And thank you so much again, Professor Henrique Leitão, for these interesting questions. And maybe we can move to the parallel sections. Thank you so much.